So Docker is yet another way to bundle and run applications because we don't have enough of those already. But this is just the latest iteration. Okay, so our goals in this workshop is to teach you how to understand how Docker works and what are containers exactly, if you don't already know, how to run Docker containers, how to create your own containers, how to use Docker Compose, and how to run projects that already have Docker configurations, and how to add support to projects that still don't have the support. And you'll also learn how to run Cake. So as for topics, first we have a small overview on all things Docker. Then we have the installation step for those who already haven't done it. Then we go over the Docker CLI, after which we move to Docker Compose, then to building images, and then we containerize a Django application. Yeah, so overview. What is Docker? Does anyone know? The Docker engine is a tool for managing and running Docker containers and other resources it manages. So it builds, pushes, downloads, and runs container. There is a separation between container image and a container. That is for a reason. And it also manages stuff like network configuration, storage volumes, and container configurations. And the Docker engine is actually controlled by its REST API. Even the CLI uses the REST API to communicate to the Docker engine. So you can expose the Docker over a network if you need to. Most of the time that doesn't happen, but on maybe CI environments might let you do that. So this is a graph sort of showing how the Docker works. So this would be the actual Docker that you install. It just comes with the CLI as well, that is able to communicate with the Docker engine. On Windows and on Mac, this actually runs inside a virtual machine, and the Docker CLI just communicates with the engine inside the virtual machine via the REST API. Also, tools like Kubernetes and then some other similar tools for this reason can use the same REST API as the CLI to manage the Docker. So what are containers and container images? Containers are sort of like sandboxed processes. They don't actually, I know many people like to sell the idea that okay, containers are like virtual machines, but not really. But no, they're not. They're just processes that have been isolated from other system resources, or actually just the main namespace where you usually run all your stuff. Basically I explained this already, but they're not virtual machines. You cannot run other operating systems in containers. You can only run stuff that has the same kernel as you're currently running on. So this is why Windows and Mac need the virtual machine, because they need the Linux kernel. Although on Windows you can also run Windows containers, but I haven't ever done that and I don't really see a reason to. And on Linux, the isolation is handled by namespaces and C groups. I won't go into detail what exactly do those do, but they just sort of limit the resource access to specific process groups. So you can have a group of processes that only see a certain part of the file system, for example. And container images themselves are a bundled file system actually, and then they also contain some configurations and maybe default settings for launching the container processes. And this is a sort of comparison between virtual machines and containers. You can see you sort of lose the operating system, or guest operating system layer there. But that also means you actually need to run the same kernel as the host. Although usually in the cloud you'd probably still have a virtual machine under Docker, so in reality your stack might even be bigger. You just if you get a virtual machine from Google Cloud, even Kubernetes, they still run the Kubernetes on a virtual machine. So, but it's nicer to manage containers, I'd still say, than virtual machines. This is a sort of comparison chart between processes, containers, and VMs. So containers have all the same stuff kind of that processes do, but they also have more stuff in the sense that they have the images, they have more flexibility in terms of the environment, and you get more isolation than just running processes. On VMs, of course, you get even more isolation. You can run anything, but the images are usually larger than container images. And of course, you could just run processes and do the C groups and namespace stuff yourself, but that would be kind of stupid considering there's a tool that is made for the purpose of managing those for you, and that is Docker. So why are we moving to Docker? Yeah, that is the primary reason. We want to make Paul's life more difficult. No. So application bundling. We can actually build ready applications if we use Docker. Right now we just ship source code and run them on the server, but with this we can bundle everything into a single package and ship that and run that on production as well. Then we get the integrity, which means our deployments are exactly the same as they were when they were tested, assuming we implement them properly, of course. And we also have a more standardized environment where to deploy stuff, but it can still be very flexible because you can run a lot of things in containers. And then we get portable deployments. So the plan is to, I know many people have had issues setting up development environments because some requirements are out of date or something of that sort of problems. But in the ideal situation, we'd just pull some image and run it locally and then make code changes accordingly. And it works because it works in production, so there's no question of some requirements breaking. And then we also get the added benefit of having the versioned releases, because those are kind of required with Docker. And if you really want to look, you can, well, I had the link there, but maybe we can look into that later. So where to get Docker? So the next topic is using the actual CLI itself. So there are 4, I think, relevant types of resources managed by Docker that we must pay attention to, which are containers, images, volumes, and networks. And containers are the actual processes that run or are stopped because Docker saves the state as well. And images are the things you create your processes based on. And volumes mount something inside containers. It doesn't actually have to be a file system. It can be something you can mount, for example, cloud storage as well, even if it's not on your disk. But most commonly you mount either a named volume or your local file system, so you can make changes inside the container. And networks surprisingly just connect things together or don't. So containers by default run in a very isolated environment, and it shouldn't have any access to any shared resources or, well, basically anything outside the container itself. And it is possible to selectively give access to certain things. You can connect it to your host network, for example, and expose a single port between the container and the host operating system. Or you can do that between two containers, so they get access to each other via some way you have specified. But everything like that has to be explicitly decided. They don't automatically just connect somewhere. And the file system itself is also an isolated environment. You can delete all files in there and nothing will happen to your host system or any other container for that matter. Only if you have mounted some file systems there, then it will. And you can also give containers some selective pseudo rights if you need to, for some reason, have those in the container, which means the container can then technically escape the isolation which is managed by Docker. And then we have the images. So the images store like general configuration, such as what command to run by default, maybe what ports it should expose, maybe what volumes it should have and where. But by default it doesn't actually do anything. If you run a container which says, okay, I want to open port 80, it doesn't open it unless you tell that to the Docker engine. But you will see that the container has this kind of configure. It's more of a suggestion that should be done. And then it contains the file system, which has the entire dependency environment packed inside the Docker image. So when you run the process, it sort of unpacks it. Well, not really, but effectively yes. And then you can access all the files you have packed inside the image. And there's a lot of available images on Docker Hub. You can use the images to, there's stuff like databases, Nginx, Python, Node, a lot of the stuff you'd find on open source software anyway does have a Docker image. You don't have to go building those images yourself. You can just go to Docker Hub and look if there's an image and then use that. Then we have the volumes. They essentially are the same as network ports are for networking, where you can open a single port to a container. You can mount a single directory inside the container if you want to. So there's some different drivers available. I haven't actually used any of the fancy drivers, but I know there's Google Cloud Storage, for example, where you can directly mount some cloud storage on the file system inside the container, for example. But I'd say most commonly you just mount some files inside the container from your host system, especially when developing. So then when you make code changes, for example, you get them live in the container as well instead of having to rebuild the container. Yeah. And then there's the named volumes, where if you really don't care where the stuff is stored, you don't want it on your host OS in the sense that you need to manage it, you can use a named volume which Docker will sort of manage. You just tell it, okay, mount this named volume on this location, and then that will be persistent data. Because if you don't use volumes, every time you stop a container, it will wipe all the changes you've made inside the file system. So you need to sort of use volumes for having persistent storage between reboots. Networks handle networking between containers and the host, and I don't actually know any fancy drivers here, but it also has a different kind of network drivers you can use, where I'd guess the Kubernetes, was it Istio, the mesh network, could probably be a network driver for containers. So you could have a mesh network driver for some reason if you wanted to. But usually you just tell it to, okay, share connection with this container, or share with the host, or something like that. Now, most of the resources can and do share the same commands for managing them. So you just have Docker and then the resource type, and then you can list them or remove them, inspect them, or the prune is kind of when you are running out of disk space and you just want to delete everything you don't need, you run that. And then of course the creation command. Only difference is that Docker images actually need to be built instead of created, but that